We are taking a look at lesson 6.1. Lesson 6.1 is about forces, specifically Newton's second law. Some of the key questions. What do forces do? And what's the difference between force and energy? Well, let's get right to it. We welcome back to the center stage here, our muscle man. He's going to be putting some forces on objects, starting with a file cabinet. You can see there he's putting a force on the file cabinet because, well, it kind of looks like he's pushing on it, but also you can see because of the vectors. There's an applied force and the total force, and they're the same because in this particular simulation, I have taken friction out of the equation. There's no friction on this particular run. Let's take a look at what happens as he pushes, and then he stops pushing, and then he starts pushing in the opposite direction. Let's see it. Alright, so a very simple little demonstration, and we're going to watch it again, this time with a graph. Watch now as the motion is graphed before your very eyes. So there you see, while he was pushing on the file cabinet, we have here a change in the velocity. The y-axis here is labeled velocity in meters per second. What happened right here? What was going on? Did you happen to notice? We see that there's no apparent change in the speed. The speed, or the velocity, I guess you would say, is at a constant, well, for all practical purposes, 4 meters per second. And then something happened whereby the speed or velocity decreased back down to just a little bit below zero. You can see that the file cabinet starts moving back. It was very difficult to get it to stop perfectly. Alright, so if we were to draw this in our notes and label these portions here, we would say, well, during this part there was a force being applied. During this part there was no force applied. And during this part there was again a force being applied, and we could take a look and note the direction of those forces. So next I want you to take a look at a little game we're going to play here. As you can see, the graph is completely different than what you just had. Well, maybe not completely different, but subtly different. Alright? I want you to predict what happens in this particular scenario. What's going to happen? Look at the graph. We have a change in the speed. Alright? Starting from rest, the file cabinet is going to move at a speed, it's going to increase its speed to 2 meters per second. And then what happens? Then we see that this graph, this slope steepens, don't we? What does that mean? Then the slope is flattened out. What's happening there? And then we see a change in the opposite direction. Alright. Well, you've had a chance to look at this and think about it, perhaps make some guesses as to what's going to happen. Let's put it into motion. So here's my question to you. At what point was the force the greatest? And how would we have been able to tell that by just looking at the graph? I think you would agree, by looking at the size of the vectors, that the greatest force was applied in slowing the file cabinet down. And do we notice here that the speed decreased by the most amount in the least amount of time during that portion of the graph? In other words, the slope is very steep. Did you notice what happened here? There's a slight what you'd call a discontinuity, or in other words, a change in the slope. It goes from a shallow slope to a more steep slope at this point for a brief time. Did you notice that the force increased? And then, of course, here, no force was being applied. The object in motion remained in motion. Forces are not required to keep an object in motion. No force was being applied at this point here, and yet the object remained in motion. There is a very important lesson. Alright, let's do one more before we call it quit. I have another graph for you. This one looks, I don't know, maybe you think it looks complicated. What's going to go on here? What's happening? Think about this. Don't just wait till I'm going to press the go button here. Take a moment and even pause if you want. That would be very helpful. And just think about what's going to happen here. Map out where you think forces are being applied and their strength as well as their direction. Map also the points where there aren't any forces acting on it. Take a moment and just pause right now. Alright, I'm going to press play. Hopefully you paused it. Here goes. Alright, as time runs out here, the file cabinet would have kept moving. I just chose to stop the simulator at that point. A force is not required to move it. So during this final portion, no force is being applied. But it does, the file cabinet that is, the file cabinet has energy. And I want you to separate that in your mind, okay? Forces aren't required to move things. They're required to change the motion of things. So anywhere where you see a change in the motion, here, no force, no change in the motion. Here, there's a slope on this graph. That's a change in its speed. It's changing because a force is being applied. Here it's changing less, but it's still changing. A lesser force is being applied in the same direction. Here the slope has changed, so a force is going on the other direction. Alright? Take a look at the questions that follow this lesson and try to answer them. Well done for following along. Hopefully you paused at the right times and you did your job. Thanks. See you next time.